This is 3 steps to sketch with function transformations, and we're going to look at an example where we transform the parent function, the identity, and we're going to use transformations to graph this graph, y equals 2 parentheses x plus 1, and we'll use the table method to do this. All right, so just a reminder of what we're graphing and how we're graphing it. And here's everything we need. So we have our 3 steps to sketch outline on the left. We have a table and we have a blank grid. And the first thing we want to do is note that this is a transformation on the parent function, y equals x. So let's just abbreviate that PF. The parent function is y equals x. And that'll be helpful because we have to start our table somewhere. All right, so let's jump in and analyze what transformations are going on here. So we have one of each. We'll start with horizontal, and that's in the parentheses here with the x. All right, and we know we should think of solving when we are applying horizontal transformations. And if we were solving, just quick scratch work, x plus 1 equals 0, we know we would subtract 1. So we're going to move left 1 or subtract 1 from our x's. Okay, so that's what's going on horizontally. Vertically, we see that 2 out front, and we know that means what you see is what you do. We see it 2 times, and we know that we are multiplying our y values by 2. So that will stretch by a factor of 2, or you were just multiplying 2 times your y's. Okay, so we have analyzed the transformations, we know what's going on, and let's go ahead and make our table and apply these transformations. So we know our parent points are -1, -1, 0, 0, and 1, 1. Those are sort of the 3 most central to the origin integer points. And now we can just make new columns to apply these transformations. Okay, so horizontally we know we moved left 1, or we need to subtract 1 from all our x's. Again, think solving. Okay, so -1 minus 1, -2, 0 minus 1, and 1 minus 1. All right, so that is our horizontal transformation, and now we can make a new column for our vertical transformation. Okay, vertical affects the y's. We should do 2 times our y's. And we have -1 times 2, -2, 0 times 2, and 1 times 2. All right. So we've transformed our table. The table's really great because your outer columns will give you the points for your final transform graph. So we are ready to move on to step 3, plot these points and sketch the graph. So we have -2, -2, -1, 0, and 0, 2. All right, there's your graph. And it's worth noting, of course, that you could just distribute this 2 through and you could plot it using slope-intercept method. It's a very basic linear equation, but it's also valuable to know how to use transformations of a parent function. So it's a great additional tool to add to your belt. Depending on what circumstance you have, you may want to use one or the other. All right, that was using the table method and 3 steps to sketch to graph a transformation of the identity function.